So what's up, guys? In our last lesson, we discussed extensively on the sources and the importance of hydrocarbons. We explained that hydrocarbons occur naturally in crude oil, natural gas, and coal. Now, since crude oil is a complex mixture of different substances, to make it useful, it is necessary to separate it into its constituent components. In this lesson, we will be focusing on fractional distillation of crude oil, which is a very effective way of achieving this separation. Fractional distillation is one of the most important separation techniques. We discussed it in detail in our lesson on standard separation techniques. It is the most common form of separation technology used in petroleum refineries and natural gas processing plants. During fractional distillation, crude oil is separated into its useful constituents consisting of different hydrocarbons with different boiling points. Apart from their different boiling points, we can also differentiate these fractions from one another by their odor, color, texture, and also the extent to which they burn. For example, crude oil fractions with higher boiling points consist of molecules with higher molecular weights that are darker in color, more viscous, and more difficult to ignite and burn. Now, let's take a look at the process involved in the fractional distillation of crude oil. The distillation process is typically carried out in a large vertical cylindrical column known as distillation or fractionation towers or distillation columns. Before the crude oil is transferred into the tower, it is preheated to about 400 degrees Celsius in an electric furnace. What do you think would happen to the crude oil in the furnace? There is no doubt that some part of the oil would vaporize. The mixture of the hot vapor produced and the remaining liquid is then transferred through pipes into the fractionation tower. Fractionation towers usually have a diameter ranging from about 0.65 to 7 meters, that is about 2 to 20 feet, and their height range is between 6 to 60 meters, which is about 20 to 197 feet or even more. To allow the withdrawal of different fractions of or products having different boiling points or boiling ranges, the distillation tower is designed to have liquid outlets at intervals up the column. Since the hot vapor transferred into the tower contains a mixture of substances, these substances separate into different fractions of different volatility or boiling points as they ascend the column and condense. The fractions of crude oil obtained during this process include petroleum gases, petroleum ethers, petrol, kerosene, diesel, lubricating oil, bitumen, and other residues. They are collected at intervals and used for various purposes. I know that you have learned a lot about fractional distillation of crude oil in this lesson, but before we conclude, let's do a simple summary of our discussion so far. Fractional distillation is the most common form of separation technology used in petroleum refineries. Fractional distillation process is typically carried out in a large vertical cylindrical column known as distillation or fractionation towers. Crude oil is separated into different fractions with different boiling points in the fractionation tower. See you in the next lesson.